On to number 13. So it says a bacteria culture initially contains 100 cells and grows proportional to its size. And then it tells us after an hour, the population has increased to 370. And A asks, what is the value of K? So let's go ahead and figure that out. So first, it says the culture grows proportional to its size. So I'm going to use P for population. When I hear those words, grows proportional to its size, then that tells me that the function is an exponential. P naught e to the kt. Now, P naught is the initial population, K is the growth factor, T is the time, and here I know it has to be positive because the population is getting bigger. So that's why it's not minus e to the minus kt. Also, we were just told P naught is equal to 100, and P of 1, because this is P of 0, P of 1 is equal to 370. So, P of t is equal to 100 e to the kt. Don't know what k is, but we can figure it out. Because P1, we know, is equal to 370 because that's the information that the problem gave us. But we also know, because we have the formula, it's equal to 100 e to the kt. So here, we can take this equation and divide both sides by 100. So we get 3.7 is e to the kt. Take a natural log of both sides. You get natural log 3.7 is natural log e to the kt. Or natural log 3.7 is equal to k times t, but t is equal to 1, right? So actually, k equals natural log 3.7. Let me write that here. We can plug in t equals 1, and I can write these as 1s. 1, k times 1, k times 1. So k is natural log of 3.7. So P of t is equal to 100 e to the, I'm going to write it this way, t log of 3.7. Why write it this way? Because I can say this is 100 e to the natural log 3.7 to the t. And now the e and the natural log cancel. Or you could also note this is just the definition of 100 times 3.7 to the t. So that makes this a little bit easier to plug into. Okay, so we found the value of k here, so this was actually the end of A. What did B ask? Find the number of bacteria after 3 hours. So we have our function. P of t is 100, 3.7 to the t. So just plug in 3, 100, 3.7 to the 3. Now we plug in 3.7 cubed times 100 is 5065.3. 5065.3. Let's see, let's do a sanity check. Does that make sense? So it more than tripled over 1 hour. So if you took 370 and then tripled it twice, you would get something fairly close. But this is 3.7, so it's way more than triple. So this number does seem reasonable. And our units are cells. Okay. C at first glance looks like it could be difficult, but it's not bad. Find the rate of growth after 3 hours. It might be a little bit of a throwback, but what does rate of growth mean? In a calculus class, if you hear rate of growth, you should be thinking derivative. So P prime of t is, let's see, this is an exponential function, so it's 100, 3.7 to the t times natural log of 3.7, because that's our rule for taking derivatives of exponentials. So P prime of 3 is, plug these things in now, 3.7 times 3 times log of 3. Also, we could note this is just going to be this number times log of 3. And that makes sense because the population is proportional to its rate of growth, P prime of 3. And so I'm going to take the number I just got in my calculator, multiply it by 3, not 3, multiply it by log of 3, and I'll get 5,564.8 cells per hour. All right, and that does number 13.